Howdy, folks. I'm Marcos. Have you ever gone outside and looked up dirt? And in that dirt, have you ever seen those wriggly pink things people call worms? You have? Great. But we're not talking about that today. Rather, we're going to discuss the groundworm's distant, yet objectively cooler cousin, the parasitic worm. Specifically, what exactly our body does to them and them to us. After all, relationships are a two-way street of communication and cohabitation. Now, before I dig into these funky little worms, I want to clarify a couple terms that I'll be using repeatedly throughout this video. Class. Classification between phylum and order. Refer to this handy-dandy triangle for relative specificity. Intermediate host. Any host whose purpose is to transport the parasite to its final host or to incubate the parasite until it is ready to brave this harsh world and make its stake into some poor, unsuspecting victim. Helminth. The scientific name for parasitic worms comes from the Greek word helminthos, literally meaning worm. Okay, now we're ready to discuss these marvelous, beautiful creatures. Up first on this journey are the trematodes. Belonging to the class Trematoda, these guys look like tiny leaves, except if leaves could swim, eat, and infect animals. Commonly referred to as flukes, trematodes love the water, so much so that they're pretty much only found in said water. Infected feces or urine reach an aquatic environment and the larvae are released. These larvae are then consumed by their intermediate host, typically an aquatic snail, to incubate. Once done cooking, they migrate out of the snail and into an aquatic environment where they then have several options. They can either penetrate the final host directly or insist themselves onto plant material or other intermediate hosts and wait for that host to be consumed by the final host. Pretty gnarly stuff, I can hear you say. And yeah, I know. Next on the roster are cestodes. These guys, unsurprisingly, belong to the Cestoda class and are generally long, flat, and segmented, with each segment called a proglotid. Cestodes can get to be disturbingly long, like up to 10 meters. That's huge in and of itself, but remember, these guys are inside people. Ugh. Most commonly referred to as tapeworms, cestodes lay eggs inside of the small intestine, which then get voided out. You can use your imagination for this, or not. That's your choice. Intermediate hosts then eat these eggs and baby tapeworms develop inside of them. The final host, usually vertebrates, then either consume the infected intermediate host or the eggs themselves, and the cycle continues. I have nothing else to say about this, just a general dislike for cestodes. Finally, thank the Lord, we have nematodes. Believe it or not, these worms belong to the Nematoda class of helminths, and are rather cylindrical and round as opposed to flat like their Cestoda cousins. Thus, nematodes are often given names like roundworm, hookworm, threadworm, pinworm, whipworm, eelworm, and heartworm. That last one has nothing to do with its actual shape, but just the fact that these helminths tend to preside in the heart. Like cestodes, however, these helminths share a similar infection cycle. Nematode eggs are laid in water or food in human environments. Nematodes, however, do not require an intermediate host to develop. They are strong, independent helminths that don't need no intermediate host to dictate their life cycle. Instead, they just kind of penetrate the host once they reach adulthood. A lucky worm could also get swallowed by the host or have their eggs ingested. Thank you for bearing with me there. Now that our collective worm knowledge supersedes that of the general public, go Deeks! Let's talk about what happens should a worm infect a human. I'm saying this now, but it should be kept in mind that the final host for all these worms are not always humans. It just happens to be that this class is about humans, thus I'm going to be talking about them. The manner in which a helminth enters the body dictates your immune response. Swallow a helminth egg, granuloma time. Get punctured by an adult helminth, antibody response to the max, baby. And since there are a couple thousand species of trematodes, cestodes, and nematodes, there are approximately a couple thousand different immune responses. As such, I'm going to cover only the basics for helminth responses because we only have like 5 minutes left. Okay, so the basics. A helminth enters the body, goes into the small intestine. Immediately, sirens go off, cells ready battle stations, all hands on deck. Tough cells in the gut are one of the first to respond and secrete interleukin 25, which stimulates production of Th2 helper cells, alongside MHC class 2 presentation from dendritic cells in the mesenteric lymph nodes. Aside time, I never realized just how many friggin' lymph nodes we have. Like, I thought it was 10 to 50, 100 maximum. But no, it's like closer to 800. Like, damn. Anyways, I just thought that was cool. Moving on. Once the Th2 cells get nice and prettied up, they begin to release interleukins 4, 5, 9, 13, and 25. IL-4 and 13 work together to cause peristalsis of the small intestine, leading to involuntary smooth muscle contractions, pretty much just trying to push it out of there. Specifically, IL-4 stimulates the muscles and IL-13 stimulates mucosal responses so that foreign bodies can get trapped. IL-9 mediates inflammation and IL-21 mediates plasma cell response, which are just antibody-producing B cells. But hey, what about IL-5, I hear you say? My sweet, golden child, IL-5. Surely you couldn't have forgotten about them. And to that I say, of course not. How could I? IL-5 isn't like the other interleukins. Rather than staying in the lower digestive system, IL-5 activates eosinophils in the bone marrow, which then produce IgE to damage the parasite. Once everything is said and done, the parasite is no longer functioning, and everything gets flushed out of your system. Simple, right? Wrong. Like I said earlier, the specific immune response differs depending on the method of infection and the infecting species. Going back to the eggs I mentioned previously. Should you swallow egg/larva, your immune system will then recruit neutrophils to surround them in your small intestines. Macrophages activated during this time, called alternatively activated macrophages, will proceed to form the granulomatous structure. On the outside of the structure are Th2 cells, dendritic cells, and eosinophils patiently waiting just in case things go awry. What happens if an actual adult helminth enters your system? Well, the major cytokines that come into effect are the same, but the intensity is different. IL-4 and IL-13 are secreted in higher concentrations to hopefully flush out the worm before it lays eggs. Additionally, IgE production can lead to basophil activation, which causes inflammation and restriction of parasitic movement, alongside the usual IgE activity of worm annihilation. Should the helminth lay eggs, however, granulomas form as previously mentioned. Cestodes, however, are different. Rather than relying solely on Th2 pathways to purge them, the immune response also uses Th1 cells. Without overcomplicating things, Th1 cells essentially boost macrophage activity through the use of interferon gamma. I have looked extensively and cannot find an article that talks about this in great detail. So if you know, please let me know. Because, kind of doing a video on this and I should know everything, but I don't. So yeah. Anyways, to quickly summarize, helminth infection causes activation of Th2 cells, mostly, which then secrete various cytokines to flush out the helminth. Finally, I'd like to rattle off a few fun diseases that can occur from helminth infection, what they are, and what type of helminth causes them. Here we go. Onchocerciasis is blindness, which is caused by the Onchocerca volvus nematode. Next up is the lymphatic filariasis, which is elephantitis, which is painful disfiguring of limbs caused by the Worcestershire bancrofti nematode. The next three are almost identical, just caused by different species. They are ascarciasis, tricerciasis, and hookworm infection, which are all symptomless infections that can block the intestines and slow growth in children, caused by Ascarces, lumbricoides, Trichurchus, Trichuria, and Necator americanus trematodes. Next up is the schistosomiasis, which is identified by rashes, itchy skin, fever, chills, cough, headache, abdominal pain, muscle aches, which are all caused by the same class of trematodes, which are under the schistosomas class. Next up is foodborne trematodiasis, which is infections that can result in severe liver and lung disease. There's a lot of them. I'm not going to name them, just know that they're all trematodes. Lastly is the cysticercosis tapeworm infections, which target brain and spinal cord, causes seizures and headaches, and most commonly caused by Taenia solium, which is a cestode. Well, that's all I have for today. If there's anything you take away from this video, is that getting a helminth infection is kind of bad. I've been Marcos, and until next time.